force of 50 million horsepower. This is the energy generated every hour by the largest hydroelectric plant in the world. A structure so colossal that it can be seen from space, an engineering feat that required enough concrete to build 63 Eiffel Towers. Today, we will take you inside the most powerful energy producer on the planet. By the end of this video, you will understand how this megastructure not only generates electricity for millions of people, but completely transformed the economy, ecology, and future of an entire region. The Three Gorges Dam in China represents the most ambitious hydroelectric project ever completed by humanity. Located on the Yangtze River in Hubei province in central China, this engineering marvel is the pinnacle of hydroelectric power generation. When it was completed in 2012, after 18 years of construction, it conquered the title of largest power plant in the world in installed capacity. Let's observe the impressive scale of this structure. The Three Gorges Dam extends 2,335 meters across the Yangtze River, equivalent to almost 1.4 miles in length. Its height reaches 594 feet, equivalent to a 60-story skyscraper. The reservoir created behind the dam extends 373 miles upstream, creating a huge inland lake that drastically altered the geography of the region. But what really makes the Three Gorges Dam exceptional is its power generation capacity. With 32 main turbines and 2 smaller ones that power the facility itself, the dam has a total generation capacity of 22,500 megawatts. To put in perspective, this single facility can produce more electricity than 20 dams the size of the Hoover Dam combined. In 2020, it established a world record by generating almost 112 terawatt-hours of electricity in a single year. Now let's explore how this monumental structure actually works. At its core, the Three Gorges Dam operates with the same principle as all hydroelectric facilities, converting the potential energy of water into electrical energy. But the scale here is what sets it apart. The dam creates a huge reservoir storing billions of cubic meters of water. This water is then released through gigantic turbines, spinning generators that produce electricity. The spillway, which is the hydraulic structure designed to release excess water and is located in the middle of the main dam, has an impressive length of 1,585 feet. Its 22 giant gates, each 26 feet wide, can release up to 116,000 cubic meters of water per second, the largest discharge capacity in the world. This system is fundamental for flood control during intense rainy seasons. Each of the main turbines weighs approximately 6,000 tons, heavier than 30 blue whales together. These Francis turbines have a diameter of about 33 feet and rotate at 75 rotations per minute. The water pressure that drives these turbines is immense, with flow rates between 600 to 950 cubic meters per second. That's enough water to fill an Olympic pool every 3 seconds. A surprising fact that few know is that the mass of water stored in the reservoir is so large that scientists calculated it can subtly influence the Earth's rotation. When the reservoir is completely full, with its approximately 40 cubic kilometers of water, the duration of a day on Earth is prolonged by 0.06 microseconds due to the immense displacement of mass caused. Although imperceptible to us, this phenomenon demonstrates the truly planetary scale of this human intervention. The construction of the dam was divided into 3 main stages, a work of impressive logistics. In the first phase, between 1993 and 1997, workers diverted part of the river flow to build on the right bank. The second phase, from 1998 to 2003, involved closing the main river channel and constructing the central body of the dam. In the final phase, from 2003 to 2012, the gradual installation of all turbines and completion of auxiliary systems occurred. All this impressive engineering was planned to fulfill multiple purposes. The Three Gorges Dam is not limited to just generating electricity, although that is its most well-known function. This colossus of concrete and steel was conceived as an integrated solution for various challenges that China faced in relation to the Yangtze River. Let's explore the 4 main benefits that this megastructure provides. Number 1. Power generation. The main objective of the Three Gorges Dam is electricity production. The energy generated is clean, renewable, and supplies industrial centers throughout the central and eastern region of China. This helps reduce China's dependence on coal-fired plants, potentially avoiding millions of tons of carbon emissions annually. To contextualize, the amount of coal saved by the dam in a single year would be enough to form a train of wagons that would circle the planet. Number 2. Flood control. The Yangtze River Basin historically suffered from devastating floods, claiming hundreds of thousands of lives over the past century. The dam's enormous reservoir can absorb potential floodwaters, regulating downstream flow. During the strong monsoon season, this capacity is crucial to protect densely populated areas. In 2020, during the worst floods in more than 3 decades, the dam demonstrated its effectiveness by containing much of the water that could have caused catastrophic damage. Number 3. Navigation improvement. Before the dam, large vessels could not navigate many sections of the Yangtze River. The reservoir transformed the upstream stretch into a deep, navigable waterway, allowing large ships to travel 1,398 miles inland from Shanghai to Chongqing. This transformed inland transportation, reducing costs of transporting goods. Cargo traffic on the river increased dramatically, with millions of additional tons being transported annually, reducing pressure on the country's roads and railways. Number 4. Water management. The dam helps manage water resources during flood and drought seasons, providing a more consistent water supply for agriculture and municipal use. Downstream regions, which previously suffered from shortages during prolonged droughts, now receive regulated flows, benefiting farmers and cities. The engineering challenges faced during construction were unprecedented. Workers had to divert the powerful Yangtze River, one of the most powerful rivers in the world, to create a dry construction site. They used a step-by-step approach, building cofferdams to contain the river while constructing sections of the main dam. Quality control was an obsession throughout construction. A 4-layer supervision system was implemented, starting with assessments from the builders themselves, followed by independent supervision companies, verifications by the corporation responsible for the project, and finally, supervision by specialized technical centers and a quality control commission. Additionally, a special group from the Chinese State Council inspected the project twice a year. The project required approximately 28 million cubic meters of concrete, enough to build a highway from New York to Los Angeles. At the peak of construction, more than 40,000 workers toiled on site. Specialized equipment had to be designed specifically for this project, including the largest overhead cranes in the world. The installation of each of the enormous turbines was itself a monumental operation, requiring millimeter precision despite the colossal dimensions of the components. One of the most impressive features is the ship lifting system. The Three Gorges Dam includes a 5-level lock that allows vessels of up to 10,000 tons to navigate beyond the dam. A complete crossing through this system takes approximately 4 hours, a considerable time for cargo vessels, but unfeasible for passenger transport. To solve this limitation, in 2015, an even more innovative ship elevator was completed, the largest in the world, capable of lifting ships weighing up to 3,000 tons, 371 feet vertically in just 40 minutes. This engineering marvel works based on Archimedes' principle, using a counterweight system. Concrete blocks are connected by cables to the steel platform that carries the ship in the water where it floats. As the counterweights descend, the platform rises, drastically reducing the time needed for ships to pass through the dam. While the Three Gorges Dam represents an extraordinary achievement of human engineering, it has also been controversial. The most significant impact was the displacement of approximately 1.3 million people whose homes were submerged by the growing reservoir. More than 1,200 villages and towns disappeared underwater, requiring the largest evacuation in peacetime history. The resettlement process was complex, with many families facing difficulties adapting to new locations. The rapid deforestation of the areas designated for resettlements led to soil erosion in many locations. Additionally, many of the new designated areas have lower agricultural productivity than the fertile riverbank lands that were submerged. This created economic challenges for communities that depended on agriculture for their subsistence. The ecological impact has also been substantial. The proportion of forested area in the region around the dam fell from 20% in 1950 to less than 10% after the project's completion. The dam changed the flow regime of the Yangtze River, affecting downstream ecosystems. Several fish species, including the Chinese sturgeon, had their migration routes blocked. The famous Chinese river dolphin, or baiji, was declared functionally extinct, with some scientists attributing this directly to the dam's construction. The reservoir also caused some geological concerns. The immense weight of the water increased pressure on geological faults, potentially contributing to landslides and localized seismic activity. Engineers continue to carefully monitor these effects, with advanced monitoring systems installed throughout the structure and surrounding slopes. But beyond these challenges, the Three Gorges Dam fundamentally transformed China's energy landscape. The clean electricity it generates has helped the country reduce its dependence on coal-fired plants, avoiding millions of tons of greenhouse gas emissions annually. In a single year, the dam can save the equivalent of 31 million tons of coal, contributing significantly to China's climate goals. The economic impact has been equally profound. The electricity generated supplies industrial centers throughout central and eastern China, driving economic growth. Improved navigation on the Yangtze River reduced transportation costs, allowing more efficient movement of goods to inland areas. The economy of the entire Yangtze Valley region has been transformed, with new industries emerging and trade flourishing. A fascinating aspect is that the dam has also become a prominent tourist attraction. Millions of visitors travel annually to witness this modern engineering marvel, generating a substantial tourism industry that benefits local communities. Observing the operation of the giant locks or experiencing the impressive elevation in the ship elevator has become an experience sought by domestic and international tourists. Engineers worldwide study the Three Gorges Dam, both as a technical achievement and as a case study in large-scale infrastructure development. The lessons learned from its construction and operation have influenced hydroelectric projects globally, from technical innovations to more comprehensive environmental and social considerations. The Three Gorges Dam remains a testament to human ambition and engineering mastery, a structure that literally changed the face of the Earth. It represents both the tremendous potential of renewable energy and the complex trade-offs involved in megaprojects that transform natural systems. The challenges faced and overcome during its construction expanded the boundaries of what is technically possible, inspiring a new generation of engineers to dream even bigger. Our ability to harness the power of flowing water has evolved dramatically from simple water wheels to structures like the Three Gorges Dam. As we face climate change and growing energy demands, hydroelectric power will continue to play a crucial role in our energy matrix, with lessons from projects like this informing more sustainable approaches for the future. As new technologies emerge, hydroelectric plants are becoming more efficient and environmentally responsible. Advanced fish passage systems, more aquatic, life-friendly turbines, and sediment management approaches are being developed to minimize the ecological impacts of future dams. The Three Gorges experience has been invaluable for these advances, showing both what works and what can be improved. Now that you've seen inside the world's largest power plant, click the like button if you found this fascinating and subscribe for more videos exploring the most impressive achievements of world engineering. Thank you for watching, and we'll see you in the next video.